In this video, we will talk about logically equivalent statements. We say two statements are logically equivalent if they have the same truth values. We denote by this notation here. Now we want to determine if these two statements are logically equivalent, not P and not Q, and not P and Q. We are given these two statements. We want to denote if they are logically equivalent. So basically, we want to create truth tables for these two statements and see if their truth values are the same. We will try to put truth values for both the statements in the same table. So we need P, we need Q, and for this part, we need not P, we need not Q. Then we need the combination of the two, not P and not Q. Then we need P and Q, and then we need negation of this part, not P and Q. Now let's put down all the possible combinations of truth values of P and Q. We can have P true, Q true, P true, Q false, P false, Q true, and both of them false. So now we are ready to fill out these columns. Not P, we are just negating P. So we'll have false because we have true here. Next we have true, again false. Now we have false, so not P must be true, and again true. Next we want not Q, so true here, not Q must be false. False for Q, not Q must be true, and then false, and then true again. So now we can find not P and not Q. So that will be simply the combination of these two. Then we'll get this column. So false and false is false. False and true is false. True and false is false. True and true is true. These are the truth values for not P and not Q. Next, we look at the column for P and Q. For that, we can just look at the columns for P and Q and combine them by AND. The first row, we have true and true. This will be true. The second row, we have true and false. This will be false. Then we have false and true. This will be false. And the last row, false and false is false. Now, finally, we can get this last column. This column will be simply the negation of this column P and Q. So negation of true is false. Negation of false is true. Then this one will also be true and true. So now we are ready to compare these two expressions, the truth values for these two expressions. We have them in two columns in this table. So we are looking at this column and this column. So we can see they are different. They are not identical. So that means we can say the statement not P and not Q is not equivalent to not P and Q. Let's look at another example now. So here we want to see if P or Q or P and Q and P or Q and R are logically equivalent. So we'll again do that using a truth table. We have P, we have Q, we have R, and we want to look at the truth values for these two combinations. For the first one, we need P or Q, we also need P and R. Then we want to combine these two by OR. P or Q and, or P and R. We are done with the first expression. Now for the second one, we have P or Q, which we already have it here. So we can just use that one. And we combine that with R and R. So now we need to look at truth values for all the possible combinations of truth values of P, Q, and R. All three can be true, 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 false. So basically we have 4 truths for P and then false. And then for Q, we have true, true, false, false. And again, true, true, false, false. For R, we have true, false, true, false, true, false, true, false. So if we write this way in a pattern, we get all the possible combinations of truth values of P, Q, and R. Now we are ready to fill out these columns. P or Q, true or true is true. True or true is true again. True or false is true. True or false is true again. Next we have false or true, which is also true. False or true is true. And false or false is false. And the last one also false or false is false. Next we want P and R. P and R, so we are looking at these two. True or true is true. True or false is false. Next we have true or true. Again, true. Next, true and false is false. False and true is false. False and false is false. And the other two are also going to be false. Now we are ready to calculate this column. This column is simply this column and this column combined with OR. So we have true or true. So this will be true. We have true or false. This will be true. True or true is true. True or false is true. True or false is true. True or false is true. False or false, we have false, and the last one is also false. So these are the truth values for the first expression. We'll also calculate the truth values for this last column. We are looking at P or Q and R. So P or Q, we have that here, this column, and we are combining that with R. That will give us this column. We combine these two with logic AND. So we have true and true, which is true. We have false and true, which will be false. Then we have true and true. This will be true. We have false and true. This will be false. We have true and true. This will be true. We have false and true. This will be false. And the last two are also going to be false. False and false. So now finally we compare these two columns, because those two expressions are the ones we want to test if they are logically equivalent. So comparing these, we can say that the first expression is not logically equivalent to the second one because the truth values are not identical. For example, you can see on the second row, we have true here, but we have false over here. They are different. Also for the fourth one, we have true here and false here. They are different. Also this one, they are different. That means these two are not logically equivalent. If they were logically equivalent, we would get exactly the same truth values.